Good evening, everyone. So it's 7 p.m. and we are about to start. So thank you all for coming and participating in the community. This event, at least Gophers community, was under the radar in Vilnius for quite some time. So we, with several like-minded folks, thought why not recreate it. So this is the first event, hopefully one of many to follow. Like when I'll give a short intro what we want from this event and what are our goals. So we decided that, that for people to come, you need to have great speeches. That's one of the key elements apart from networking. And we want that everyone would be welcome, not depending on their level. Are they beginners, intermediate level, or experts? So having said that, we decided to have different tracks of talks, and that's how today's event will be structured. So for first talk, more entry-level talk about logging will be presented by Narunas. Second talk, intermediate track, will be done by Mangardas. Unfortunately, yesterday he got COVID. So we'll try to manage the situation and he'll join us online on the screen. It would be a bit naive to find a change last day for a speaking slot. And Mangardas will be talking about reverse proxy in Go using HTTP libraries, and it's really interesting when I saw the description of the talk. And the final talk will be the expert track about using eBPF in your Go programs and how you can linger deeper into Linux kernel and all the advanced features in operating systems. So yeah, that's what's planned for today. And we have some snacks and beverages for networking afterwards, and even we have some presents prepared for you. So please listen carefully to the talks. That can be a very tangible outcome for you. And these beverages and presents wouldn't be possible without our sponsors today, which is Realm. They love Go a lot, as I do. So we thought of partnering here and give a round applause for them, and I'll invite Rob to drop a short message on why are we interested to be here. Rob? Sam, please come. You understand English, you can speak in English, right? Yeah? Okay.
Thank you very much for that introduction. Thank you, Rokas. Hello everyone, as Rokas has explained, I'm Robert and I'm the co-founder of Realm, alongside Jem, who is just standing up there, a little photographer in the back corner. We're sponsoring tonight's event, so do fill your boots with alcohol and food and stuff at the back there. Rokas and I's relationship, I think it spans back, 2018? I think originally? Something like that. We've been friends for a long, long time. And now we're partners alongside, so Realm and Cast AI are partners, and we help them essentially find Go engineers, staff for their company. The company was originally called the Golang Guy, and as the name suggests, it was just me on my own working with Go for I think it was about 4 or 5 years, and then I got together with my friend Jem, who we used to work together, and we created Realm. So we're now a team of 10, and we span all over the world. We've got an office in San Diego in the States, and we work with companies and startups and enterprises, essentially helping them find Go engineers. We also do a little bit of Rust as well. So that's us in a nutshell. We don't bite. Come and have a chat to us. If you're looking for Go engineers or if you're looking for a job, come and say hi.
Okay, so all these talks are boring. That's not what you came here for. So Narunas, the stage is yours.
Yeah, you should hear me. Give me a moment. Yeah, so it seems it works. Okay, cool. So hello everyone. My name is Narunas Kapočius. I'm a software engineer at Cast AI, and today, as you see, I will give you a brief introduction into structured logging in Go. Yep. So a little bit about myself. I work at Cast AI as software engineer for last 1.5 years. What's interesting, it's first job for me as a professional software engineer. Before that, I worked as a DevOps or an SRE engineer for 4 years at a couple of companies. And my educational background is computer networks with emphasis on Kubernetes networking. So yeah, and as Rokas told, we have 3 tracks of presentations. So this one is tailored for beginners. And I would like to ask who could you raise a hand who used Go less than 1 year? Okay, that's good. So I think for you it will be interesting. And anyone who is using Go from 1 to 3 years? Okay, and more than 3 years? Okay, cool. So it's equal on all sides. Okay, so let's start. Could you guys, take a moment and look at this function? And if you have anything to say, raise hand. Don't hesitate.
Why so big?
Yeah, that's good. Another one. Okay, so this incredible piece of software was created by me a couple of months ago, and what it does is basically, takes kubelet file and parse it and basically updates some kubelet arguments according to some rules, right? So, at that time I didn't use ChatGPT. It took some. It took for me some time to write it, but now with ChatGPT probably it would be faster. But yeah, what is kubelet file? It's just a text, right? As every file. So the same is with logging. Non-structured logs are just sentences or strings of text, and usually, non-structured logging is used in places where human interaction is needed. So, for example, some CLI tools, for example, kubectl, and etc. So it's great to understand for humans, but if you have a distributed system with multiple microservices, it's it would be hard for you to check something or find in the logs if your program processes thousands of requests per second. So here comes structured logging, and it's nothing fancy. It's just the same text or string of text split it into key value pairs, so basically JSON. And as it's JSON and key value pairs, it's great for machines to search, analyze, aggregate. And that's all. I think we can finish my presentation. This is the essence of structured logging. No, I'm joking. So, but what about Go? Go is interesting in that sense that Go for a long time didn't have a standard package in its standard library for structured logging. And because of that, community stepped up and suggested their own packages, and few of them got traction. The most popular one is the Logros. Actually, it's not actively developed anymore for some time, just only security patches are introduced. But what is interesting is that it's still widely adopted, and people are still introducing it into the new projects. Out of curiosity, I tracked the number of package imports throughout the couple of months, and it's still increasing, right? So people are using it because it's simple, understandable API. However, it has its downside. It's slow, and in the systems which processes thousands of requests per second, you expect that your program process requests as fast as it can, not just spend more time on emitting logs. So here, Zap package was introduced by Uber. Do we have any engineers from Uber or ex-Uber? Okay, cool. Few hands. So nice to meet you guys. It's good to have you here. So, Zap is extremely good at it. There is one more, zero log, which is, let's say, faster in some terms than Zap. But yeah. And interesting that with Go 1.21, which was released, I think, in the autumn last year, Google team, which is leading Go development, actually introduced the structured logging package into the standard library. So at the end of the slides, I think after the meet we will share them. So there are a few good talks from the Google team, how they made slog, and in a nutshell, they used the ideas of Uber and Zap. Okay, so that's about packages. So let's read some code. As this talk is tailored for beginners, I thought it would be interesting to analyze several patterns, how the loggers could be initialized, right? Because there are a couple of them. I will cover four of them. And the first one is the global logger. As the name suggests, it's nothing fancy. It's just, you have you have a global logger defined here. You have init function, which configures the logger, sets its output format, log level, and in the main function you just call the logger. And for beginners, maybe you might not know, init function, it's let's say a feature of Go language. It's basically reserved function which is run before the main. Some may say that it's anti-pattern to use it, but actually I checked the Kubernetes API server, and it uses in its functions to enable features flags for it. So yeah, it's simple to use global logger, but it might be okay for small programs. But as you know, global variables and global state is not what we expect in production systems. So yeah, and of course it's hard to test it because we don't have any dependency injection. Another pattern, it's a second from the fourth that I will cover. It's a bit, let's say, different from the first one. So in the main function we define logger, we configure it, and we pass the logger when we propagate through our program as a parameter or attribute for every function. What is nice in this scenario is that on each function we actually can make a copy of the logger and add additional fields if we want. So probably it's the main advantage. But as every disadvantage has its own every advantage has its own disadvantage. So if you have larger developers team, it might be that in the long term and probably pretty fast, the patterns how you name the fields will, skew, and you will have a problem in long term. The third one, which I see every day at my work life, is the service pattern, and it's interesting in that way that we basically in the main function, as in previous examples, define the logger, configure it, but we pass it not just to regular function, but we are passing it to the service constructor, which is here. And service object has the logger, and every method for the service object could call it. So it's nice. We have a dependency injection. We can mock it. We can test it. And the fourth one, probably the most advanced we can call, is the contextual logger. So if in the program you're using contexts, let's say you're processing some kind of requests, you're using context, you can save the logger as a key value pair in the context. And in the handler, you can just get it from the context and log it. So this way, you can use logger to log some additional context for your request. So for example, user ID and etc. So yeah, so that's about the logger initialization. And there are not much talk about tips and tricks about logging, but there are few things that I would like to mention. So good log statement should say what, where, and when happened. And I would like to emphasize this, that implement log levels carefully. So, as always, think before you type. Don't throw errors where they are not needed. Only throw an error, log the error where it's actually actionable. Because in long term, you will suffer from alert fatigue, and yeah. And of course, if for some reason you log sensitive information like password secrets, don't do that. But if you have to do that, use reductor functions, which would remove those secrets from your statements. And as always, logging is just one pillar of the observability. We have two others. It's like tracing and metrics. So if you want to have like application which is observable, you have to have all of three. And we are approaching the end of my presentation, but so now what? We know how to initialize the logger. We know how to write good log statements. Our program does that. But what to do next? We still have to use some kind of tool to process them, like to have easy access, or you can do aggregation analysis. So in general, in open source community, there are two teams. Let's say Grafana stack and Elk stack. So Elastic, Logstash, and Kibana stack. I'm more familiar with Grafana stack, but never mind which stack you're using. If you're using Kubernetes, you will need to have some kind of agent which runs on the node. So probably it runs as a daemon set, which basically gets the logs from the pods and pushes them to your aggregation tool. And if you are from enterprise, I think you are familiar with Splunk. I worked with Splunk for a few years in my past life. And of course, there's Amazon CloudWatch and Google Stack Driver. And I want to show you a quick demo. It won't be a sophisticated one, but give me a moment. Yes? Yes, I forgot it, but I think it's quite calming, right? Okay, sorry, forgot about it. So give me a moment. It's not sharing. Okay, yeah. So maybe I can make a text a bit larger. Can you see it, or should I make it larger a bit? I take silence as a yes. So, on the left side, we have a structured application, which basically use structured logging. And on the right side, it's just regular prints. What it does is like every fifth second, it prints something. And in both cases, I try to match the similar output. So I built this code and deploy it as a deployment in Kubernetes. And as well, I have set up Loki. Let's make it bigger. Yeah. So you see, in a structured logging case, we have Loki for us already parsed that log levels. Even looking at this, we can say that how many info and warnings we had, and those unknown levels are just plain text with non-structured logs. What is nice is that when you have structured logging, in Loki case, these things are called labels. And in a high level, if you're not familiar with Loki, it's just basically labels. By labels, you can have indexes. So in the large, if you have large logs, storage, it allows to search faster, and we can filter by it. As well, what I like about Loki and general about structured logging is that I can parse the fields and, for example, print just message, or inside it, for example, it has the increase variable. I can print it here as well. Right. Okay, so this is a super easy demo, but it's I want to emphasize that having structured logging is not enough. You have to have some tools. So yeah, that's it. Maybe you have questions.
So out of those four formats of logging. Hold on that, I will give you the microphone. Okay, so out of those four formats of logging, which one do you prefer in your day-to-day work, and why?
You mean
those four ways of
yeah, so I mostly use, and probably in our team and company, we are mostly use service pattern, and in some places we start to use contextual logger. And I forgot to mention that if you're starting some project, choose your logger carefully, because probably after some time you won't. I would say it would be hard to rework it, because if it works, why change it? So yeah. Okay.
Any tips for tracing user between different requests? Okay. Hi. Any tips for tracing the user between different requests?
Yeah, so I haven't shown, but for example, you can use open tracing, like initialize it together with your logger. And I don't have it right now in my example, but in Grafana, there's a tempo tool, which is for tracing, and you can use it to trace requests or users, like the path. Okay. Yeah, so that's it. So thanks a lot for your attention, and I hope you enjoyed. So
Thank you, Narunas. Now we'll get our unfortunate guy online. So bear with us for a short technical break. If anyone wants to, go to a restroom or somewhere, now is the time. But we'll be here in a minute or two.
Yeah, I am. Okay. It works on my end. Let me reach. What about now? No, not yet. Let me try sharing. Okay. Cool. Let me know when can I start. I have a YouTube lag of around 10 seconds, so this is very funny. Cool. Okay. So let me find my first slide. Cool. So hello, everybody. I'm MJ. I'm one of the engineers working at Cast AI. And sadly, today I'm not able to join you live because of I got 2 strikes on my test and home arrest basically for the rest of the week. And you should hear that from my voice. So in addition to Cast, I'm basically active contributor in the open source community and having my own projects. And I would like to talk to you today about HTTP2, reverse dialers as a pattern, with a small story why you should care and why it's needed. So cool. So inspirations and kudos first. Let's go with that. Basically, all this pattern is inspired by Golang Builder, reverse dialer builder in a Golang community. It's official tool to use to build Go, test Go, and all these things. Antonio Ojea, you can follow him on Twitter. He basically, I used to work with him in a previous job, and he's an amazing networking guy. Follow him for more tips on the Twitter. Very approachable, open source. Basically, author of IPv6 in a Kubernetes ecosystem. And I've borrowed few demo materials from Hussein Hasser, a YouTuber basically covering technology. So before, let's jump into that. Spoiler alert, I'm not going to talk about HTTP3 quick. It's not part of this talk. This is intentional. HTTP3 basically is, if you're familiar with the topic, you know that it moves the parsing of the packets into the user space, basically into application layer. So it's kind of responds to HTTP2 some of the drawbacks, and it's totally different talk of its own. So for this one, what I want to show, HTTP2 is enough. So let's get into that. HTTP2 versus HTTP1. Before we go into the nitty-bitty details, basically each and every time you're making a request to web server, which serves HTTP1 or HTTP11, and you query for index.html file, and it gets you return like, yes, I have these files served, but together with this, you need to get CSS, jQuery, all these assets. And what happens, your browser in the background opens multiple TCP connections and starts pulling those assets based on that. And if you open any web page, which is HTTP1, when you load the page, you will see that sometimes you get throttled because there is a limit how many TCP connections you can open. And that was one of the main biggest drawbacks of HTTP1. Where HTTP2 came, what we do, we multiplex everything through one connection. And this has very big play when you're running your infrastructure, let's say in a cloud-managed environment. You bound your applications and you start noting in SNAT exhaustion, basically errors, because you have too many open connections. So, bit of history of HTTP2. HTTP2 previous name was Speedy, basically developed by Google, and after that it got converted to HTTP2. It was very closely developed with a Kubernetes ecosystem because it was trying and helping to solve a lot of issues in that particular area of basically applications. And if you're familiar with that, previously, if you do kubectl port forward and you introspect headers, you would see protocol Speedy, and basically Speedy is just HTTP2. So let's switch gears a bit. WebSockets. So WebSockets is a communication protocol providing simultaneous two-way transmission over TCP channel. So basically, HTTP gives you TCP channel. You can switch it, upgrade it to WebSockets, and you get basically, you can reuse the same connectivity and do two-way communications. And we're getting closer a bit to the reverse dialers as a pattern. But when you read these things, this looks a bit suspicious. It's like, it's strange. Like you scroll through the issues of Golang community and you find these things where like proposal, let's add WebSockets over HTTP2. And multiple people, including Antonio, is like, here, this is how you can do it. And 2003, November 2, still nothing. We have a very familiar library, URL in the bottom, Gorillas WebSockets. I think most of you have heard of it, maybe use it. I would ask raise of hands, but sorry, can't see you. So it's the same, kind of supported, kind of not. So you can basically hack it a bit. So kind of sad because we don't have a normal WebSocket support in a Golang as for HTTP2, but that's not another big issue. Like it's an issue when you're doing web applications, but let's not go in there. So reverse dialers. But before we go there, pull and push architectures. Usually pull architecture is when you have a deployed agent somewhere on a remote clusters or remote edge sites, might be your Raspberry Pi, might be moving car, trolley bus, whatever. And your agent just pokes your API console and is like, hey, do you have anything for me? Hey, do you have anything for me? What about now? And at some point, it's like, yep, cool. You get updates, you get state changes and things like that. Cool. Push architecture is where client, the edge device, remote device, calls once, creates a TCP session, and says like, this is where you can find me. If you have something, send me. So you avoid this poking piece. Basically, the downside is that you have to have long-lived connection. The plus side is it's a less connectivity, it's less basically new connections. And this is where the reverse dialer comes in, and cool. I wanted to put some diagram on this, and I looked online and I found this, and it's like, I have no idea what's happening here. If I need to explain it, if I would be in the audience, might be easier, but online hard. I went to Antonio. Antonio gave me this basically in his repository, and I was like, okay, this is a bit cleaner, but yeah, okay, cool. So I started drawing myself. This is the usual situation, and sorry, I'm building long up around for that. Usually you have a load balancer, you have some firewall NAT included, sometimes in one or another side of the load balancer, somebody asking for a web server page. If you're a bigger enterprise, you might have application gateway serving multiple load balancers, things like that. If you're a bit paranoid about security, you might add a third-party traffic scanner into the mix somewhere in that. And this gets to the place where having inbound traffic is almost unsustainable. Outbound traffic is usually easier, hence the pull and push architecture. So what you can do is use outbound connectivity for your inbound traffic. Basically, it's kind of a bit circumventing firewalls in a way, but what you do, you deploy a client being some component close to your web server somewhere. You proxy it to the web server. You establish some server outside your infrastructure path. You get two outbound connectors basically to the server. And well, having those two connectivities, you can reuse this one and change the direction and start sending traffic our way around. So let's get to the interesting part on a code, and we're getting closer. So how to implement that? Usually you would need two methods. So this is a server side, basically the closer to the actor box. You implement the connect method and you implement the proxy method. Connect method is the one where the remote clients would connect from and establish long-lived connections. Proxy one where you send the users in and you will send them to the reusable connection. Inside of connect method, when the client goes in, this is basically for the HTTP in 1.1 using WebSockets library. You grab the connection from the request, you upgraded it to the net.dial connectivity, and you store it somewhere in a session store. And you need to do a bit more, like to keep the session connection alive, keep it running. But as long as you have it running, you have the long-running TCP connection here. In HTTP2 is a bit more magic. It's a very boilerplate. There's a link of all these codes in my last slide, but you operate at a bit at lower premises, and HTTP has one very big caveat, which I leave it for a bit later, but mostly that is the idea of the talk. And for the proxy itself, when the request comes from the actor, you just take the request and extract the connector from the session store and just pipe it, basically go through. Cool. And on the client side, meaning the little boxy close to our web server, you implement a standard reverse proxy where on one end is the web server, on the another end is that outgoing connection session being alive. Just the difference is that traffic will go other way around. So a bit of demo time. So I have a bit show. So I have this pattern shown for the server and client, meaning you will see me starting client utilities and server utilities and hitting different URLs and going through the logs, and I will try to explain it. So first of all, let's should be okay on a size. As you're getting delayed, let's hope it is. Oh, demo effect. Where is my Docker? Is dead. Let's bear with me for a second. Demo gods are not happy today. Cool. So I have simple web page running. And that's not a web page, but content is this. Basically, it's HTTP port running web page. I open it from the browser, and I can see in a logs, I getting request basically HTTP1 because this is a non-HTTPS server. So now the next thing is I have a HTTP1 server running, which acts as a utility which accepts both incoming connections, and I have a remote agent connecting who says like, go and connect to my site. So now if I open URL, which is of the server, in the background, I'm getting redirected to the same URL. This works fine and nice, but let's see how this goes with HTTPS. If I do the same setup, open this, I'm getting an error, and that is expected. And the thing which I didn't mention through all the presentation is that HTTP2 to work fully must be full end-to-end TLS encrypted. Means you have to have valid certificates across the stack. So if I go to the now HTTP2 reverse dialers, it's like, I'm not saying you can't make it with HTTP1, but it's easier to make mistakes when protocol allows you both things to HTTP and non-HTTP, HTTP and HTTPS traffic. When Google developed HTTPS, Speedy, they intentionally made that it has to be encrypted end-to-end. So if I open this now through the HTTP dialer, and demo guides are not happy with me again, please trust the certificates. There's nothing malicious out there. Okay. Okay, I did demo all the way around a bit. So let me show you this way. Here we go. So it opens. What I'm interested is in the logs of Caddy. Now I see that basically I have traffic being served at HTTP2. If I try the same trick and try to basically send everything to my HTTP server, run page, and bear with me at this point, you might asking why he's showing all these things. So I see in the logs here, it's HTTP1. So now you might ask why this is important in the first place and why you should care about this level of detail. This is why. This is the main idea. If you look to any Kubernetes examples out there in official documentations, in most of the places, most of the examples in Kubernetes tells you, this is how you bind WordPress. This is how you expose your application. This is how you deploy. Only very rare examples speak about TLS, and why do you need to use TLS at the end in a pod? And what happens is, if you followed my a bit chaotic demo, then you have everything HTTP2, and at the end, something uses HTTP1, non-TLS traffic, you get downgraded. This means in your infrastructure, if you're running your containers and pods on a and don't using serve TLS server, you're basically getting downgraded from the traffic of your load balancer and Nginx running in the Kubernetes cluster to the pod. This means you might think you have HTTP2 all across the stack. You don't, because at the edge, you're getting downgraded, and this is where the performance penalties might hit. Solutions, TLS all the way. And the lower example is from the Red Hat OpenShift. They have this built in a product where you can annotate Kubernetes service accounts with annotation, which will give you certificates generated for the service name or service account. And this one, I think, is service. This is, you can use native Kubernetes certificate signing request and generate certificates for your services. And these certificates automatically become available as a secrets. You can mount them and run your applications as a TLS-enabled server and don't have this premature TLS termination in your stack. So now, before I jump to the questions, my last example is this. Like, all this reverse dialer stuff is nice and shiny. The things you can do is so funky. Like, I do this here, SH minutes. This is a Golang CLI. I got SSH into random device, which runs on a wall, on a blurred wall behind me. But the idea is that because you have a raw TCP session, now you can, and in the last example I showed, there is zero SSH involved. Basically what we do is you take user's input, bash it through the TCP connection, bash it through the other end via reverse connection, and represent the device as it would act as and look like SSH. So, and the device can change locations, can change where we are, internet IP addresses and things like that. As long as we can dial back, it just works. And with this, I'm leaving you with two links. First one is for the remote dialer, very nice small example is a fork of the Rancher reverse dialer, which uses HTTP 1.1. And the second one is for HTTP 2, basically the same ones I used in my demos. And with this, I know I'm open to questions, but it might be very strange to answer those when I have such a big lag.
So I'd say let's do the questions with a delay. That will be the best decision, minding the live stream viewers and the recording. So any folks have any questions, and Mindgrass will hear them a few seconds later.
So when HTTP 3?
when it will be live or when it will be like available. HTTP3 is already there. It's widely adopted. I think the statistic is a bit skewed because the major adopters are Cloudflare, Google, GCP, like think companies like this who kind of responsible for a lot of internet traffic, but around 28% already of the internet traffic is HTTP3. Yeah, I think, yeah. Yeah, so I think HTTP2 is already answer to that. Just the problem is that people don't use it unintentionally in most of the cases because we are not bothered to set up proper certificate trust. They do the TLS termination and re-encryption, not trusted re-encryption. So will HTTP3 will fix some things like that? Don't think you can't fix lack of certificates and lack of due diligence. It just doesn't work.
So, Mangirdas, thank you for presentation. That were all the questions we had. I'm wishing you getting well soon. We miss you in the office, and Totoro especially. It's his dog. He brings it to the office. So what's next? Yeah. So we have a final talk upcoming. It will be presented by Angie. So Angie, come here. Why we fill in the time, like if you're, everyone is welcome to do presentations here. Like as you can see, it doesn't matter the level. You don't need to be an expert in Go. You can understand well the simple things, and we'll share a link for talk submissions. And that's the only way to keep this going is by having contribution from you guys. So looking forward for your applications. Okay. Yeah, it works.
Okay, hello. So strange to hear my voice. So about me, I'm Andrzej Matusowicz, work as CastAS staff engineer. I'm in this company for 3 years now. And in my team, we are focusing on security products for Kubernetes. So mostly building Kubernetes security related products for customers. And agenda, what I will talk about, problem statement, what are we doing and why this talk can help you. Some examples of how we build our initial security architecture. Then I will talk a bit about general Kubernetes security and what concepts you can use. Then we will go through eVPF overview in both kernel or user space. So mostly Go will be here on user space. So that's about it for Go. So sorry if you wanted more.
I will talk a bit about storage and in general interesting lessons and tips we learned while building it. So first, what's the problem in general about runtime security? So detecting malicious behavior is hard, and it's especially hard to do it with a low false positive rate. So in kernel doesn't know about Kubernetes at all. So it's also a challenge how to attach Kubernetes context. So for example, how to know what is the pod, what is the namespace. And also users wants to have low overhead. But the issue that with runtime security, we need to collect a lot of data, and we need to do that with a minimal footprint, because we run daemon set on each node, so that affects performance quite a bit. So this is initial architecture. It's really simple. So we have daemon set. So we have a pod running on each node. Then we send data to the server and store it. And then we process the data and detect anomalies. Now let's look a bit into each of the components and think about, in general, what events we can collect from the kernel. So if we look at the engine, it runs as a pod. So on each startup, we have binary execution. So this is our Go binary, which is runs at startup. We have some DNS lookup to our server. We have TCP connection to the server. And in general, we can collect like all syscalls, statistics for each syscall. Then if we look at the server, it's similar. It starts a server binary. There is TCP listen to accept client connections. We have DNS lookup to the server. We have TCP connection to the server, and also a bunch of syscalls. And finally, if we have storage, we have binary execution. We have TCP listening. We have file writes, because this is a storage. It writes access a database. We have syscalls. And we have curl, which downloads some utilities. But actually, the last one is a bit strange, because this is what we don't expect. It downloads some file from the GitHub, and let me try to open it. Yeah, so this is the file, and actually this is a crypto miner, and this is real case what we found in one of the clusters. So now the question how we can detect that and how we can alert and block such malicious runtime behaviors. So first, let's try to look into Kubernetes security and see if it can actually help us to do that without anything, developing any custom tools. So what you can do, and it's recommended to do, is apply security context. So on each Kubernetes pod, you can specify a security context, which I marked as yellow. So there are a few features. They are mostly maps to Linux security features. So you can have AppArmor configuration. You can run as a non-root user. You can specify a bunch of security context flags for container. For example, to not allow any file modification, to run as a read-only file system, to apply seccomp profile, which will allow only have limited set of syscalls. And you can also drop capabilities and specify only which you want. But this is actually quite hard to do. And can you raise your hand who actually does that on your Kubernetes clusters to like configure security context? I expect at least someone from CAST. Yes, one. Thank you, Rokas. Yeah, so it's really hard. But if you apply security context and you want to get validation that actually your team members follows that, you can also set up pod security admission. So this is the easiest way you can do. So you specify a label on your namespace, and you can set mode for privileges. So for example, you can set restricted mode, and it will automatically follow Kubernetes best practices. But this is not flexible enough. There is like set of rules, but for beginning, this is like a really good start to make it more secure. So next, there is network policies. In our example, if you remember, something happened and malicious binary was downloaded from the internet. So we can actually try to prevent that with network policies by just blocking it. So don't allow any traffic to the internet. So then it should work. So we can specify ingress and egress. We can specify which pods we allow. So for example, in this example, I apply network policy for database, and I allow only front end to call it. And also I allow egress to private CIDR block. So the problem with this approach, it works in some cases, but if I already call public internet, for example, I call cloud APIs and or something else, I will have a lot of public IP addresses, and specifying them all here, it's impossible, because like you have a lot of IP addresses. So that's one of the limitations of network policies, but it's also like a good start to work with it. I will not ask how many of you apply it, because we're not, so it's hard. Yeah, so Kubernetes security doesn't cover all cases. It's hard to configure. And also, even if you secure it, you can still exploit through allow syscalls, because most of the applications already use a bunch of syscalls. So like downloading binary from the internet, you will most likely already have such syscalls for just normal other processes. So that doesn't fully help. Now let's talk about eBPF and how can it help. And also I want to ask who of you are familiar with eBPF? Maybe. Okay, nice. So we have quite a few hands. That's good. Yeah, this is a strange slide. So we have YouTube 2005 and 2000, it's now. So now before, you see it was like a static page, and now there's dark mode and it's modern. So do you know which technology allowed to go from here to here? No, something else. Do you have any front-end developers here? Yeah, so it's JavaScript. Actually, JavaScript allowed to move a lot faster. And I will come back to that later. So with eBPF, what we can do with eBPF? We can do networking observability, we can do security stuff, and we can do tracing. So there are a lot of projects already building on eBPF. For example, Cilium, which is a Kubernetes CNI. There is Falco, runtime security, and Pixie observability. There are a lot of SDKs, how to use it. So there is one for Go, there is one for C++, for Rust, and there is kernel. So in kernel we have verifier. So when you load BPF program, it's verified by the kernel. And there are helpers, and it also can run on Windows and Linux, but I haven't tried Windows. I think it's strange. So what are the main selling points and why would you use it? So first, it's safe. So if you write kernel module, you can crash your kernel. With eBPF, there is verifier which actually verifies that you don't crash the kernel, so which is great. Yeah, so it's flexible. Like you can add it quite easily. Like if you compare it to kernel module, and it also performant. It's the same as native kernel module performant. It compiled just in time to the kernel with machine code, so you don't actually get performance overhead compared to traditional ways of capturing observability events. And in this diagram, there is a few tools. So there is audit D, Go audit. They are both written in Go. And there is eBPF-based tooling, so which is a lot faster if you compare that to traditional ways of auditing kernel events through user space. So this is how traditional eBPF program looks like. So basically write a subset of C. So it's almost the same as C language, but there are a few limitations. So you need to select what are you hooking into. So this is a trace point. And for this case, every time syscall is executed, I will get here, and I can do something with that. I can observe syscall, I get arguments, I can read it, but there are a few limitations. Like I cannot have global variables, I cannot have loops. So there is unroll, but this is to prevent infinite hang, because you don't want to hang your kernel. And also there is limited instruction set. You can use inline functions, but they should fit into the instructions, which are limited. And you can only use defined helpers. So that means if you want to do something more complex, it should be defined already in the kernel. So it's like a bit more strict if you compare that to kernel module, but you can still do a lot of that with eBPF. So we can collect data and we can send it to user space to analyze, because in kernel it's limited, so usually you just want to capture something and send it to user space. And due to that, there are two ways. You can use push-based or pull-based approaches. With pull-based, you specify a map. It can be a hash map, can be array, can be there are many of them, but you can choose based on your use case, specify what is the size, and then when you want to output something, actually write to the map. And the value here will stay in the map. Or you can use push-based model, which is more like event-driven. Then you specify perf output and use perf event output, and it will push to the perf buffer. So once you do that, now you can go to the next slide. Okay, let's go to the user space. In user space, like the library to go is Cilium's eBPF. It's a native written in Go. There is another library which is a C wrapper, but there is overhead of CGO. So I would recommend going with Cilium's eBPF native Go library. So the library already does a lot of stuff which you don't want to do. Like it generates C code, it compiles it to bytecode, and there is a lot of methods how to load it into the kernel. And there is all methods needed to interact and get the data. So what is actually, and the most important part, you specify perf reader. This is your event map, which is also generated. You have a channel, you read from the buffer. Here you have raw bytes. So then you can decode that bytes to your struct, so it should match, like layout should be the same as in kernel. So in C you can specify a struct, and to go ahead and specify a struct, and then you can decode binary fields. And it's really important to make this loop fast as possible. So usually you will have buffer channel, you will export, and then you will process it in separate loop, because you don't want to block kernel events reading. If you block that, in kernel you still have a fixed size, so you will just drop the event. And you don't want to drop events, especially which are security related. Another approach is to use pooling. So with pooling, you can have a timer, like for example, for each second, I will get the data from the BPF map. So this function will look up kernel and will fetch a value from the kernel, and you can access it in user space. So there are both benefits to use one or another. For example, in kernel, you can have like a statistics of syscalls, because the frequent, and then you can every second get the aggregated statistics. So this is similar to Prometheus metrics if you use that. And okay, once we collect the events, so how do we detect anomaly that something is wrong? There are two approaches. One is rule-based. Basically, you just have a function which tells you if this is anomaly or not. And another way is to use machine learning and get some score and have a threshold. So how do you think which method is better? First one. Okay, any more? Yeah, actually, the best method is to use both. So there are a few. So there is data which is useful for machine learning, but if you use only one method, then you will not. You will, with rules been changing. Of course, you will have like a lot of ifs, like a lot of lookups, but then you can strictly find some strange behaviors like crypto miners. But with machine learning, you can do more like anomalies which spawns across multiple clusters, like increased CPU usage. Some strange syscalls started to happen, which is usually harder to capture with simple rules. A bit about storage. So since we have a lot of events, choosing storage is also quite difficult, and it can be a talk on its own. But what we want from storage, we want optimized for writes, because we have a lot of writes. So we also want to keep time series, but the problem so far why we cannot use Prometheus, Mimir, and like time series database, because we have a lot of cardinality, and that will just kill traditional time series database. And we also want flexible aggregations and querying to analyze the data and process the data. So this is what we currently end up with doing, and it was pretty well. So we're using ClickHouse. It's a column-based database. So the first point took it from their web page, that it's like the fastest and most efficient. But actually, after trying it, sometimes it feels like magic, like how fast it can aggregate data. And it's SQL based, so it's almost like traditional SQL, but there are a lot of its own helpers. So it's really easy to start with, but how fast it can ingest data is just suitable for such case. And now I just want to talk about general lessons and tips that I learned and I think are more important and more interesting. So first is which kernel parts to hook. So once, like for example, you want to track TCP connect event. Every time TCP connection happens, you want to get such event. So you can go to Linux source code and look into TCP implementation, and you can find that there is TCP connect event. And maybe you can look into SOC, which contains IP address, a source and destination tuple. Actually, it's not true, because TCP connect fills SOC address only after it exits. And there are many such examples. Then you think, okay, so this function is suitable, but actually it's not, and you end up using multiple functions, capturing temporary state just to get the event, and it gets complex quite soon. So there is also issue that it runs on different kernel threads sometimes, because it's network related, and to find which thread it runs on can be tricky. So then like looking into all the examples, how to find it, and like you need to know the implementation of networking stack. Yeah, this one I found really interesting. You can actually capture the whole packet. So you can attach to C group egress, and there is one for ingress. So every time packet is transferred through through network, you can send that packet to the user space. And then you can use Go library, Go packet to parse the packet, and then you can get all layers. So you can build pretty cool tools like distributed Wireshark, where it captures like traffic from your whole cluster, for example. Capturing traffic before TLS. So if you think that if you use TLS like end-to-end and you are safe, then think again, because you can actually capture traffic before it gets encrypted with uprops. So you find a function, for example, in Go, TLS implementation is written here. It goes to TLS, con.go. You find this function, write record locked, which accepts data, then it will encrypt it. And you hook into this method before it gets encrypted, and you basically get the whole data, which is unencrypted. So there are a few tools actually which does that, and for analysis, they are mostly written from Chinese people for some reasons. Not efficient events processing. So currently, what issue do we have? We have two charts. So at the top, we see how many events do we export. So this is a rate per second, about 600. But actually, from the kernel, we pull about 400,000 events. So this is not efficient because we need to pull a lot more events than we actually send. So we have user space filtering, and we're working on filtering in kernel, but there are like few limitations on flexibility, how to do that in C, and with limitation of eBPF. But you should track such metrics and try to improve it to have the same export rate, because this is actually where overheads also gets and you consume CPU. Kubernetes context. So in kernel, you can get process ID and you can get cgroup ID. But there is no such concept as Kubernetes pods, and you need to find them. So if you're using, you can find them by process ID. So this is the directory where cgroup lives, and this is a file where you have container ID, and from there you can find the Kubernetes. Or you can use cgroup ID, and by cgroup ID you can find it from mapped cgroup file system. The problem that this is slow, because you should iterate a lot of subdirectories just to find it. And this is not always a good idea by process ID, because if you have temporary lived process, which is killed, so you run some binary, in 1 second it's killed, and in user space, you don't have that information anymore, so you actually lose context. So we end up using C groups with a lot of optimizations, caching, how to do that, so it works. The problem with, in general, with buffers, so we have a lot of buffers and buffer sizes. In kernel, we have events queue with a size. Then we have perf event buffer in user space, which is a memory map file with some size. We have Go event channel with size. Then our approach was first to try batching data before sending them through HTTP, compressed with Snappy. And then on the server, we have a batch, and we save to the database. So we have a lot of batches and we have sizes. And how to choose the correct size. If you set to high size, you will have a lot of memory usage. And if you set to low, you will drop events. So one improvement which helped, to reduce one batch, and instead of batching and sending through HTTP, we use gRPC stream. So we actually send every event through stream, and we reduce one batch, which actually helped quite a lot to have more stable data ingestion and lose less events with just changing from HTTP to gRPC streaming. And also really useful metric to track how many events do you lose from the kernel. If you're losing events, that means some buffers need to be adjusted, or maybe you're processing them too slow. Profiling. Pyroscope, so this is distributed profiling tool. Now it's part of Grafana. So you install it to your cluster, you set up to send metrics, and then you can profile, for example, CPU for every of your pod in real time from any pod, and you can accumulate statistics. So in eBPF, the best case to have syscall as the first line. If you have syscall here and you don't have any of your own business logic, it means that it efficiently uses events processing, and it just uses cpool to pull events. This is what you want. If you have here like some other functions, it means that you can try to optimize it. And almost the last slide. So I used ChatGPT once, and it was used to find a C group path by C group ID. So this is internal C group kernel inode, and to find the path which is needed for Kubernetes. And we deployed that to customer cluster. We tested that on our cluster, but customer's cluster was 2 times bigger, and they started to complain that it actually consumes a lot of CPU. So we profiled with pprof, and we found that actually this function consumed like 60% of the CPU. But of course, there are no excuses. This is what I did. Yeah, so thanks. And questions if you have any.
Hello, thank you for the presentation. I have several. You were comparing rule-based eBPF rules and AI-based. So what kind of AI do you talk about? Because I think that if we know about Java ecosystem and we do GraalVM, then what we can do there is we can run this GraalVM warm-up machinery, and then it will, let's say, load the classes. So why not do the same? Because it will basically produce a tree that will say, hey, we are allowing these system calls, but why not? Why do you say AI? Why not just say we are going to just whitelist several, or for example, maybe we can audit the container and then just allow several of them.
Yes, a few reasons. So, what happens if during container start anomaly doesn't happen, but it will happen after 1 hour. For example, you installed command and control tool, and from remote you installed some binary. So if you start analysis, you will not find anything suspicious, and after that it can happen.
But what I meant is that if you allow some syscalls, and then this command and control will just fail because it will not have access to others.
Yeah. So for that, if you capture syscalls and your application is already doing a lot, like for example, the application writes to the database, it connects to the internet, then the spectrum of syscalls will be such large that installing new binary will still use the same syscalls. So it's really hard to block by just syscalls.
But then why not audit also the network? Why not also audit the network traffic? Because if you can just run the container, capture everything that it does, and then, okay, we are allowing a lot of stuff, but let's say we just do this like warm-up.
Yeah, so this is what we actually are doing. So we are capturing good traffic for some time, and then everything else what is not part of this traffic can be denied. But the problem with some cases that you can have a pod which is like auto-generated pod, and it can run user program. So you have like a public facing page where user can deploy something, and then that container can change quite a lot. Like, so you cannot capture like just some spectrum. It will change all the time. So it's like it's hard to capture the state.
That means that our security boundary is not sure. We're not sure what we're defending against. We don't know what we are doing then.
Yeah, so it requires to have a lot of data for already bad traffic, like to have a lot of deny lists, get examples of packages which are malicious.
Yeah, I was wondering a bit about the Kubernetes container context retrieval. Would it be possible, at least in networking situations, to determine that it's actually a pod by using network namespaces? Because I imagine that each container should be having its own individual network namespaces, and retrieving that would maybe be also a possible way to determine that, yeah, it's indeed a container.
I cannot find it. Yes, here. Yes, so it's a good question. You can even find it by pod IP. But if pod runs as host network, so you are on host namespace, host network namespace, and you can actually have more than one pod. So then you don't know what is the pod. So yeah, that's like one of the main issues to have host network.
Okay, thank you. Very nice presentation.
You mentioned that it's useful to have a lot of data that is already known to be malicious.
Mm-hmm.
How do you collect this data, and do you share that data with anyone?
So do you want to buy it? Yeah, so this is why there are a lot of these companies exist, because this is your know-how. How do you collect it? So you can have like honeypots where you deploy some site and you just wait for attackers. You can find it on, there are like some open source lists, but yeah, it takes also time to collect. So you always need to, for example, in our case, we collect a lot of data, but we also need to analyze it manually just to check if it makes sense what's happening. And then yeah, it takes time. But we are also experimenting with some machine learning models just to help catch like a small amount of bad traffic, which can help us to classify it later. So yeah, it's quite a complex problem. Okay, then if no questions, thank you.
Okay, so I hope you enjoyed the talks and that were useful. At least I found it interesting. But now we'll test how well you were listening. I'll bring some presents to give you some incentive, like why should you do this? So we have 3 presents. Anyone follows Pragmatic Engineer blog? Not Pragmatic, but George Lee. Yeah, Pragmatic Engineer. He's hugely popular, and this is his latest book. Next one is System Design Interview. I bet most of you saw this too. And the last present would be £50 in Amazon to buy a book you want. If it's not one of these 2. And this is how it works. We'll run a quiz, based on what was in the talks. And the winner will be selected not only by correct answers, but how fast people answer. So if we have a tie, it will be based on time. Okay, so we'll give a few seconds for people to log in. And how we will select which present goes to whom. First place selects what he wants, second what remains, and the third one, yeah. Do anyone need more time to connect, or can we start? Oh, okay. Let's wait. Let's wait. No pressure. Nobody's waiting. All good? Cool. So let's go. Oh my God, 48 players. So, press enter. I feel a lot of focus in the room. Okay. Almost everyone got it correctly. So time will tell. Question 2. Yeah. Nobody's waiting for when the time ends, right? Okay, more distributed answers, Q. Really curious to see the results. Oh. Okay, we might not select a winner by time, right? At least the results are entertaining. But we have quite a leaderboard here. Okay, game on. Let's go. Yeah, we had questions. What about HTTP3 after a presentation? So many emotions. so we are off into the questionnaire. Let's see what's next. I'd say Bob. You see? Oh. That's the most important thing you need to remember. Yeah. You see, sometimes you need some luck to win, right? Okay, Oleg, Mantas, and Domas. Mantas is fastest, but he makes mistakes. This is regarding the last presentation. But the answers are tricky. But everyone, like you see, you were listening. Okay, 2 remaining. Focus, focus. One is not clicking. Okay. They lost the hope. Okay. Last question, and we'll have a winner. 3 winners, actually. Okay. I'm proud of you, guys. You came here not only just for beverages, but you're actually listening. Let's see who won. So nobody overtook Oleg. So please come to the... Hey, congrats. Let's wait for the second place. Oh, but could we go back and see the third place? It was DM. Yeah. Okay, so give a round of applause for these folks. Now it's your time to choose. I'd say they're all fairly similar values, so choose on... You know, everyone will know what you chose, so...
I'll take the gift card then.
Okay. You like flexibility, right?
Yeah. Okay, I'll take the system design.
Awesome. So, congrats.
Thank you.
Okay, so don't run away. Let's network, talk to each other, code, hobbies, anything, we're here, right? And as I said previously, we want to keep this rolling, and you might ask when the next one will come. And we'll do once we have a good set of presentations, like that we feel that everyone would benefit from. And that requires input from you and the community. So I'll post some links in social media where you can submit your talks, and I guess we'll see you next time. Thank you.